Ancient giant dinosaur revealed. Brazil discovers giant dinosaur linked to Spain, hinting at ancient land bridge. Scientists in Brazil have identified a new species of giant dinosaur that lived more than 120 million years ago, offering important clues about how prehistoric animals moved between continents when the Earth's land masses were still connected. Now let's dive deeper and explore every layer of this story on our AI podcast.
Welcome to today's deep dive. So, I want you to imagine you're driving a bulldozer.
Okay.
Yeah, you're on this incredibly dusty, just sweltering, road-widening project. It's 2021, and you're near a municipality called Davinopolis in Brazil, specifically in the state of Maranhão.
Right. So just a totally routine day of infrastructure work.
Exactly. You scoop up a massive load of dirt, you dump it, and sitting right there in the displaced earth is a femur.
A thigh bone.
Yeah, thigh bone. But, I mean, this isn't just any bone. You jump down from the cab, you walk over to it, and you realize this single piece of bone is 59 inches long.
Which is what, roughly 1.5 meters?
Yeah, exactly. So you haven't just, delayed construction for the day. You've actually just unearthed a 120-million-year-old passport.
A passport that proves South America and Europe used to be the exact same neighborhood.
Right. And to really grasp what was pulled out of the ground, you have to visualize the scale.
Oh, definitely.
Because if you were standing next to this thigh bone, you would be looking it right in the eye. I mean, it's as tall as an average adult human.
What's fascinating here is that image, the mundane collision of modern infrastructure and deep geological time. That is exactly where our mission starts today. We're exploring this massive recent fossil discovery in Brazil that is actively redrawing our understanding of the ancient world map.
And what really gets me about this bone is the density.
Oh, yeah, because it's stone.
Right. When a bone sits in the earth for 120 million years, it isn't bone anymore, is it?
No, not at all. The organic material has been entirely replaced by minerals.
It's solid stone.
Yeah.
So the construction workers and the paleontologists, they weren't just lifting a big bone, they were extracting a boulder shaped like a femur.
Yeah, they likely required heavy machinery just to hoist it out of the trench.
Which is just wild to think about.
But it's a perfect indicator of the animal's original sheer mass. I mean, from
Right.
that single staggering piece of evidence, along with, a few other fragments they found, scientists calculated the proportions of the entire creature.
And how big are we talking?
We're looking at a sauropod that stretched around 20 meters long.
20 meters.
Yeah. If you want a modern equivalent, just go downtown and picture two standard city buses.
Okay.
Now park them end to end.
Oh, wow.
That is the physical footprint this animal commanded as it navigated the early Cretaceous landscape.
Okay, let's unpack this, because we have a massive stone-heavy bone from a Brazilian construction site, and we are claiming it rewrites ancient geography.
Right.
But before we get to the map making, we kind of have to look at the biology, because if I'm playing devil's advocate here, my first question is, how do researchers definitively know they found a brand new species?
That is a great question.
Because if you just have a 59-inch thigh bone and maybe some tail fragments, why isn't this simply a really mature, oversized version of a dinosaur we already have on record?
Yeah, and that is the exact hurdle paleontology teams face with every single excavation. The team analyzing this material, they were led by Elver Mayer from the Federal University of the San Francisco Valley, and they didn't just rely on the tape measure. They had to dive into the intricate mechanics of comparative anatomy. They are looking for a highly specific biological fingerprint.
Right, because size alone isn't really a species marker. I mean, a Great Dane and a Chihuahua are the same species despite the massive size difference.
Exactly. So they have to look at the structural engineering of the skeleton. And the skeletal engineering of this animal had some highly specific anomalies.
Like what?
Well, first, they analyzed the tail vertebrae. They found a very distinct series of ridges and grooves that dictate how the muscles and ligaments attach to the spine.
Okay.
And those markers, they just didn't align with any known sauropod record. Then they examined that massive femur again and documented a very prominent bulge on the bone itself.
Now, when we say prominent bulge, we aren't talking about like a disease or a deformity.
Right.
Because in skeletal anatomy, a bulge usually means an attachment point.
Exactly. Bone is a dynamic tissue. It shapes itself based on the stresses placed upon it over an animal's lifetime.
Right.
So a prominent bulge on a femur is an insertion point for immense musculature. It's where incredibly thick tendons anchored the leg muscles to the bone, which is what allowed this 2-bus-long creature to support its own immense weight.
And actually move forward.
Yeah, it dictates the animal's entire biomechanical gait. So it's not just that no dinosaur has ever had a ridge or a bump before. It is this specific combination.
Oh, I see.
The unique ridges on the tail acting in concert with the specific muscle anchors on the thigh. This exact biomechanical cocktail had literally never been observed together.
So it's kind of like finding a classic car buried in a barn.
Yeah.
It has the headlights of one brand, maybe the bumper of another, but the chassis and the engine mounts are entirely unique.
That's a great analogy.
Once you put all those pieces together and look at how the car actually functions, you just have to admit you are looking at a completely original model.
That's exactly how to visualize it. And that specific biological fingerprint placed it squarely in the category of a newly discovered sauropod.
And the sauropods, just to ground us really quick, those are the iconic long-necked plant-eating titans, right?
Yeah.
The family that includes Brachiosaurus and Diplodocus.
They were the undisputed heavyweights of terrestrial history. And finding a previously unknown branch of that family tree, it adds a really crucial layer to our understanding of the ecosystems in ancient South America.
It's just amazing we found it at all.
Well, you really have to appreciate the sheer luck of the preservation. The only reason we have this biological fingerprint is because of where it died.
You mean the dirt in Maranhão?
Specifically, the ancient river systems that define that area 120 million years ago.
Oh, right. Because it can't just lay there.
Exactly. For a bone to survive that long, it can't just lay on the ground and decompose in the sun. It requires rapid burial.
So it got covered up quickly.
Yeah. This animal likely died near a river delta and was quickly entombed in fine sediment, mud, or sand. That rapid burial sealed it off from scavengers and oxygen, which kicked off the millions of years of mineral replacement that turned it to stone.
It really makes you appreciate the human element of pulling it back out of that stone. I mean, you were a scientist called to a dusty road project, and over the course of days, this behemoth just slowly reveals itself, inch by inch.
It must have been thrilling.
Actually, paleontologist Leonardo Kerber, who worked on the research, captured that anticipation perfectly. He noted how, as the excavation progressed over several days, the true scale of that enormous femur finally became undeniable.
Wow.
You can almost feel the weight of history settling over that construction trench.
And because of that undeniable uniqueness, the ridges, the biomechanics, the sheer scale, it earned its own official classification. The team named it Dasosaurus tocantinensis.
Dasosaurus tocantinensis. It has a real weight to it.
It does.
And that specific species name, Tocantinensis, is a direct geographical anchor.
Right?
Because it's named after the Tocantins River, which is one of Brazil's major vital waterways. And the eastern margins of that modern river sit right near the excavation site.
Which is a brilliant tribute to its resting place.
Yeah, they explicitly tied this ancient titan to the modern Brazilian landscape where it finally resurfaced.
But as we established right off the bat, the resting place of Dasosaurus tocantinensis is where the local story ends.
Right.
And the global mystery begins.
Yeah, because discovering a new 20-meter-long sauropod near a Brazilian river is an incredible day for paleontology.
Yeah.
But the narrative takes a really sharp turn when researchers started looking for this animal's closest evolutionary relatives.
Right.
If we map out its family tree, where does its closest cousin live?
And that is the detail that truly reframes our understanding of the era. When the researchers ran the phylogenetic analysis.
So comparing those unique tail ridges and femur bulges against every known dinosaur in the fossil record.
Exactly. They found that the closest known relative to our Brazilian giant is a dinosaur called Morelensis.
Okay.
And Morelensis was discovered in Spain.
Okay, here's where I need to jump in.
Sure.
Because obviously they didn't swim the Atlantic Ocean.
No, definitely not.
We all learned about Pangaea and the shifting continents in school. But what trips me up is the timeline and the sheer mechanics of a family tree stretching across an entire ocean.
Right.
If the ancestors of this Brazilian dinosaur walked from Europe to South America, how long does a migration like that take? Are we talking about like one really adventurous herd of sauropods getting lost?
No.
Or is this millions of years of slow generational drift across a landmass?
It is absolutely the latter. It is generational drift across a completely different version of our planet.
Okay.
If we connect this to the bigger picture, this isn't a story of a single herd going on a transatlantic road trip. It's about populations slowly expanding their territory over countless millennia.
Slowly pushing their boundaries.
Yeah. The researchers mapped a timeline suggesting that around 130 million years ago, the ancestors of these sauropods expanded their range from Europe down through what is now northern Africa and eventually into South America.
So they were basically just gradually eating their way across a contiguous landscape.
Yeah.
But to really conceptualize that, you have to mentally delete the Atlantic Ocean.
You have to completely erase it. During the early Cretaceous period, roughly 120 to 130 million years ago, the Atlantic Ocean, as we know it, just didn't exist.
Right.
South America, Africa, Antarctica, Australia, and parts of Eurasia were all locked together in the supercontinent of Gondwana.
Now, I know we throw the word Gondwana around a lot when talking about dinosaurs.
We do.
But we rarely talk about what it actually felt like to stand on it.
Right.
I mean, these massive sauropods were making this multi-generational trek from the Iberian Peninsula down through North Africa and into Brazil. What kind of world were they walking through?
Well, it was a world fundamentally different from today's climate. The early Cretaceous was significantly warmer.
Okay.
There were no polar ice caps at all. The sea levels were much higher, which created these vast, shallow inland seas.
Oh, wow.
Yeah, and the areas connecting these massive land masses weren't barren deserts. They were lush, humid, and covered in dense vegetation. We're talking ferns, cycads, and the very first flowering plants.
So plenty of food.
Oh, yeah. It was essentially an endless, all-you-can-eat buffet designed perfectly to support herds of animals that were the size of buildings.
Here's where it gets really interesting for me. Because we look at the modern map, and we see the coasts of Brazil and West Africa looking like two puzzle pieces that have been pulled apart.
They match up perfectly.
Right. But when Dasosaurus tocantinensis was alive, that separation was just beginning, wasn't it?
Exactly. The tectonic plates beneath Gondwana were already under immense stress. Convection currents deep in the Earth's mantle were welling up, and that was creating a rift valley between South America and Africa.
Like the East African Rift today.
Very much like that.
Mm-hmm.
But tectonic plates don't snap apart overnight.
Right. It's a slow process.
They separate at roughly the speed your fingernails grow.
Wow.
So maybe a few centimeters a year.
So when these dinosaurs were migrating, they weren't looking at an ocean.
Not at all.
They might have just been crossing a valley or like splashing through a shallow rift system.
Yeah.
A system that would eventually, millions of years later, flood and become the deep, treacherous waters of the Atlantic.
That is the exact mechanism. They crossed before the Rift Valley became an impassable oceanic barrier. And that's why finding Dasosaurus tocantinensis in Brazil, with its closest cousin in Spain, is just so vital.
Because of the timing.
Yes, it acts as a biological timestamp. It tells us that 130 million years ago, the land bridge was still viable enough for these colossal animals to literally walk across.
But the clock was ticking.
Right. By the time our Brazilian sauropod died and was buried in that river sediment 120 million years ago, that window was rapidly closing.
It totally changes how you view a fossil. You know,
It really does.
we tend to look at dinosaur bones as these static relics of dead animals. But a fossil like this is actually a dynamic marker of a living, breathing ecosystem. An ecosystem that didn't care about the oceanic borders we accept today as permanent facts of nature.
Max Langer, a researcher at the University of Sao Paulo who reviewed these findings, he perfectly synthesized the scientific weight of this.
What did he say?
He noted that this discovery expands the known diversity of early Cretaceous sauropods in northern South America, but more importantly, it highlights the biogeographical connections with northern Gondwanan regions and Europe.
Which is the academic way of saying, this bone proves the continents were connected and these specific giants walked across the seams before they tore apart.
Precisely. Every fossil is a data point.
Right.
For decades, we had data points in Europe and North Africa. Finding this highly specific biomechanical fingerprint in northeastern Brazil gives us the exact puzzle piece we needed to trace an ancient, borderless ecosystem that stretched across half the globe.
It is genuinely incredible to think about the journey of the knowledge we just unpacked today.
It really is.
I mean, it starts with an everyday road crew in 2021, sweating in the Brazilian sun, doing routine infrastructure work.
Just trying to widen a road.
Right. Their heavy machinery hit something dense in the dirt. It turns out to be a 59-inch stone-heavy thigh bone. And from that single excavation, scientists mapped the anatomy,
The unique muscular attachment bulges on the femur.
Yeah, and the unprecedented ridges on the tail. And they realize they have a brand new 20-meter-long species on their hands.
And then by following the evolutionary breadcrumbs of that specific anatomy, they find its closest relative sitting thousands of miles away in Spain.
Right, and that connection forces us to completely reevaluate the ground beneath our feet. It forces us to visualize Gondwana.
This lush, humid, borderless world.
Yeah, where herds of 2-bus-long animals simply graze their way from the Iberian Peninsula down through North Africa and into South America, stepping right over the seams of a rift valley that would eventually become the Atlantic Ocean.
It's mind-blowing.
And the reason this matters to you, the reason a bone found in a Brazilian construction site is so much more than just a neat paleontology fact, is because it proves that our planet is deeply dynamic.
Yes.
The geography we live on, the oceans we navigate, the continental borders we view as absolute permanent truths, they're all just temporary phases in planetary history.
It is a really humbling reminder of the scale of geological time versus human time. We build our roads and our cities on top of a landscape that is constantly, albeit slowly, rearranging itself. And honestly, it leaves you with a truly staggering thought to mull over next time you're stuck in traffic.
Oh, what's that?
Well, if a 120 million-year-old, 20-meter-long giant, an animal the size of a pair of city buses, was found entirely by accident just because we were widening a road in 2021?
Right.
How many other unknown bus-sized monsters are resting just a few feet beneath the pavement of our everyday commutes, simply waiting for the next shovel to...
Okay, one question for you. What role did the ancient supercontinent Gondwana play in allowing dinosaurs to travel between regions that are now separated by oceans? Don't forget to comment it. Thanks.